So, you want to learn AI. I mean, who doesn't right now? It feels like it's moving at 1,000,000 miles an hour, and jumping in can feel, well, impossible. But it's not. We've put together a clear roadmap, a step-by-step guide to get you on your way. Let's get into it.
Because that's really the goal, isn't it? We're not just talking about dipping your toes in. We're talking about real mastery, going from someone who's just curious to someone who can actually build amazing things with this technology.
And yeah, that is the million-dollar question. The amount of stuff out there, the articles, the videos, the courses, it's just overwhelming. Honestly, it feels like you're standing at the bottom of a gigantic mountain with no idea which trail to even start on.
So you know what? Let's just embrace that feeling. For this whole journey, let's think of it exactly like that. We're climbing a mountain. It's going to be tough, for sure, but with the right map and the right gear, it's also going to be an incredible, totally rewarding adventure. Every single climb, no matter how big, starts with one thing: packing your bags. Before we take a single step up that mountain, we have to make sure we've got the essentials. This is our foundational toolkit, the gear that's going to support us all the way to the top.
First things first, your adventure starts with Python. It's pretty much the language of AI. And inside your Python toolkit, you need two best friends: Pandas, which is like a superpowered spreadsheet for organizing all your data, and NumPy, which is the engine that handles all the heavy-duty math. Seriously, these three are your non-negotiables.
Okay, a climber needs a map, right? Well, in AI, your map is data visualization. You have to actually see your data to get what's going on. Tools like Matplotlib or even the plotting functions built right into Pandas let you create charts and graphs in a snap, giving you a clear, kind of topographical view of the terrain you're about to cross.
And finally, before you start climbing, you check your gear. You wouldn't climb with a leaky water bottle, and you can't do AI with messy data. This part is called data pre-processing, and it's all about cleaning things up, dealing with missing pieces of information, managing weird outliers, and getting all your numbers on a similar scale through a process called normalization. This isn't just some boring chore. It's the thing that can make or break your entire project. All right, our bags are packed, our gear is checked. It is time to start the real ascent. We're officially leaving base camp and taking our first major steps up into the world of machine learning. As we start to climb, you'll see there are a few different ways to teach a machine. These are the main paradigms or approaches: supervised, unsupervised, self-supervised, and reinforcement learning. They're all fascinating, but for now, we're going to focus on the two main trails you'll take early on in your journey.
Supervised learning is by far the most common path. And this analogy is perfect. Think of it like you're teaching a student with a textbook that has an answer key in the back. You give the AI a bunch of examples, and you also give it the right answers. You showed 1,000 pictures of cats that are all labeled cat, and after a while, it starts to figure out what a cat looks like all on its own.
Now, this supervised path splits into two main types of problems. On the left, we've got classification. This is all about sorting things into buckets. Is this email spam or not spam? Is this a picture of a dog, a cat, or a bird? Then on the right, you've got regression, which is all about predicting a specific number, like what will the price of this house be, or what will the stock price be tomorrow? To tackle these problems, you're going to need your first set of reliable, all-purpose climbing tools. Models like K-nearest neighbors are awesome for simple recommendations. Decision trees are fantastic because you can actually see why they made a certain decision. Random forest is basically a supercharged version of that. And support vector machines are really good at drawing a clear line between two different groups.
Okay, but what happens if you don't have that answer key? What if your data isn't labeled at all? Well, that's when you take the unsupervised learning path. Here, the whole goal is to just give the AI a messy pile of data and say, find something interesting in here. You're basically an explorer, asking the AI to help you map an unknown land.
And the most common way you'll do that is through something called clustering. It's really just about finding natural groups in your data that you didn't even know existed. Think about it. You could give it customer purchase histories, and it might find 3 distinct groups of shoppers, each with different habits. It's incredibly powerful stuff.
So how do you actually use all these models? You'll need some professional-grade equipment. Scikit-learn is like the Swiss Army knife of machine learning in Python. It has almost everything you'll ever need, all in one place. And then, when you need a little more horsepower and performance, you reach for a specialized tool like XGBoost. Okay, take a deep breath. We've made it through the forests and foothills of machine learning, and now the air's getting a little thinner. We're approaching the summit, deep learning.
This is where the most advanced, the most powerful, the most state-of-the-art AI lives.
You see, deep learning isn't something totally different. It's an evolution of machine learning, and it's all inspired by the way our own brains are structured. We go from those traditional models we just talked about to understanding the basic building block, a single artificial neuron. And then we scale that idea up into these massive, deeply layered networks, like the transformers that power things like ChatGPT. It's all about that idea of scaling up.
When you're operating at this altitude, you need one of two heavyweight frameworks. There's TensorFlow from Google, which is an absolute rock-solid choice if you're building big applications that need to scale. And then there's PyTorch from Meta, which is often the favorite in the research world because it's so flexible and easy to experiment with. Honestly, you really can't go wrong with either one.
And here we are, at the very peak. Right now, the cutting edge is dominated by this one powerful architecture called the transformer. This is the groundbreaking innovation that made large language models, or LLMs, possible. What makes them so special is their ability to understand context in language in a way nothing before them ever could. They are the engine behind this entire generative AI revolution we're living through.
But working with these giant models isn't just about using them out of the box. The real magic is in the techniques you apply. You can fine-tune a model to make it an expert on your specific data. You can use quantization to make it run faster on smaller computers. You can use RAG to give it access to new live information so it's never out of date. And frameworks like LangChain help you stitch all these complex pieces together into a working application.
And we made it. We're at the summit. You've packed your bags with the basics, you've made the ascent through machine learning, and you've mastered the advanced techniques of deep learning. So, what now? Well, now you get to enjoy the view. More importantly, you get to start building.
With this skill set, the things you can create are just incredible. You could build a system that detects faces in photos, create your very own chatbot app, build a model to predict stock prices or spot fraud, design a recommendation engine just like Netflix's, or even a tool that summarizes long articles for you automatically. The choice is completely yours.
But maybe, just maybe, the ultimate project, the thing that will really prove you've mastered this, is to create your very own data set. Forget about using data someone else collected. Go out and gather data about something you're passionate about. It forces you to master every single step of this process we've talked about, from collection and cleaning all the way to building and deploying a final model.
So there it is, the path up the AI mountain, from base camp all the way to the summit. You have the map. The journey ahead? Yeah, it's a challenge, but it is so rewarding. The only real question left is, what are you going to build first?